Hello and welcome to KOABC. In this video, we're going to be going over how to put block code onto the Diana board. In order to do that, you will need your Arduino IDE set up, and in order to do that, you can go to Code and Tutorials. It'll show you how to download it and then all of the configurations that you'll need to do. So let's just check out the advanced version of Blink for an example. So within the examples, once you load it, everything is completely ready to go and should be functional. So I'm going to download it. Let's call this A for Advanced Blink. And this is going to create a .eno file, which is compatible with the Arduino IDE that I mentioned a moment ago. So I'm going to download that, and here it is. I can find it in my files. There are two ways to open it, and the first one is just to double click on the file and open it up. It will give you an error if you try to do this. The file ablink.eno needs to be inserted inside a folder with the same name. Create this folder, move the file, and continue. This is something that the IDE needs for it to function, and when you do that, you can see that now a folder exists called a blink, and when I go inside it, there's the file that we were just talking about. Cool. Let's look at another way to open a Arduino file. I'm going to open up the Arduino IDE, and then I'll say File Open. Here you can see all of my projects inside Documents and then Arduino, but mine was in Downloads. So if I click this, it'll tell me to make a file, which we've already talked about, and it opens that up for me. So now that we have our file pulled up in the Arduino IDE, we're going to need to put it onto our Diana board. Let's take a look at what we'll need to connect the Diana board to your device. You'll need the Diana board, this is the 4th version, and you'll need a cable that can do data transfer. So I have one that has a micro USB on one side and a USB on the other. The micro USB can be plugged straight into Diana right here, and the other side can go into my computer. I will say, before you plug this in, make sure that your Diana board is not sitting on anything that can conduct electricity like metal. Because all of these bits are exposed, if you put it on something that can conduct metal, it'll short circuit things. It'll start putting connections there that aren't intended. So just make sure you're not setting your board on any metal before you put power to the board. Now I'm going to plug this into my laptop, and we can see now that some lights have turned on. This LED over here is LED 4, and this is the power LED. So if any power is going to the board, it will be on. Down here we have LED 3, and that's one of our programmable LEDs.
The programmable LEDs can be coded, and so when we say LED 3 on or off, this is the LED that will be programmed. This LED also tells us information about the Diana board. So when we are pushing code onto it or when code is being restarted, LED 3 will pulse.
All right. How do we get it to recognize our board? You can click this drop-down menu and click whatever is available there. And now that this is bold, I know that it sees a board that it can actually send code to. Let me just unplug this and replug it in so I can show you the other way. And the other way I can do it is by clicking Tools, looking at the port, and selecting it. Now that we are here, we have a few options. So this button is called Verify, but essentially what this does is it compiles your code. So before anything can be run, it has to be translated into something the computer can read, which is 1s and 0s. And so that's what verifying does, is it will go through the process of compiling, and if it's successful, great, but if it's not, it'll tell you what's wrong. This is our upload button. This is what will actually push the code from the computer to the Diana board. And whenever you click upload, it will first verify it and then it will upload that code. So let's give that a try. So we can see a new window has come up down here, and that's our output window. So this is describing where in the process we are. So it successfully verified or compiled, and then it uploaded it. So if we go back to the board, what this code is telling it to do is it's telling it to go high for 500 seconds, then low for 500 seconds. So it's going to be on, wait, and then turn off. And so that's what we're seeing here is the blink. So this code was put on there successfully. One way to check that this is reading things correctly is to change the numbers and try uploading it again. Awesome. Now we can see this is blinking way faster, and that's because I told it to only wait 200 milliseconds instead of 500 milliseconds. So we've successfully loaded code onto the board. Let's look at a different example file. Let's do the advanced file write. I'm gonna open it up. It's gonna tell me to make a folder, which I'll do. I'm gonna select my board, and I'm gonna push it. My sketch was compiled, now it's uploading. Well, what is it doing? I can't tell what it's doing. Blink was easy to tell if it was running because it's interacting with an LED. Let's take a look at what it's supposed to be doing with this one. It's gonna be printing things out. Well, where is that? I'm not seeing the print anywhere. The way we're gonna access that is by going to Tools and Serial Monitor. And so if we go to Hints over here, when I hover over print, this input will be written to the serial monitor. You can see this window within the Arduino IDE, Tools, Serial Monitor, Tools, Serial Monitor. So now we have the serial monitor open, and let's rerun this code. Once code has been pushed onto the board, that's what it will run every time it's powered up. So there's two ways to restart the code from running. The first one is to cut power and then put power back to it. Cool. Now the board should be rerunning that code. It's initializing the SD card, which is what I told it to say. If it fails, it will tell me it failed to initialize and ask me some questions. So let's take a look at that. Is the SD card inserted? No. So let's try inserting it, and then we can try the other way of restarting the code. The code is all still on the board, but something that's faster than unplugging it and replugging it back in is this button right here. This is the reset button, so I'm just going to click that once. It'll cut power to the device, and it can start over running whatever was on it. So here we can see it initialized the SD card, completed that, wrote text to it, completed that, and now when it read through it, it wrote testing 1, 2, 3, and we can see that it wrote when it was reading out the file, it says testing 1, 2, 3. So the serial monitor is extremely valuable for communicating and seeing what your code is actually doing. And also just for fun, let's see what was actually on the SD card. So I'm gonna pull that out, and I'm also gonna unplug this. And now I have a little adapter. I'm gonna plug in my SD card, plug that into my device, and let's see what we have. So on here, these are some old files from me testing things, but I can see a test dot, what type is it? text document, test.txt, which is what we're expecting. Reopen file. And here it is, and it says testing 1, 2, 3, which is exactly what it read out just a moment ago. Even though it's not plugged into my laptop, I'm gonna show you that just by putting power to the device, it'll rerun whatever code was loaded onto it. So if I plug this in to a power source, which this is just a battery, it'll run that write to SD card code that we were just looking at. So here we are. It's running the code. I should have put something in here with the LED so it could communicate with me once it's all done. So I'm just gonna wait for a moment and hope that it finishes. All right. Hopefully that should have been enough time. And now, let's look at the SD card again and see what's on here, if it wrote anything to the SD card. All right. So I'm looking at the SD card right now. I'm pulling up test. So it says testing 1, 2, 3 in here twice. Why would it do that? So we already knew that it used to say testing 1, 2, 3, but then I ran this code again, and what does this code do? It writes to the file. It writes testing 1, 2, 3. So the second time it was run, it wrote testing 1, 2, 3 to the file. It just appended it to the very end. So this just shows that the Diana board is running the code even if you can't see what's happening with the serial monitor. Once it gets power, it'll run whatever code you put on the board last. All right, so let's load one more example file onto here. We're gonna do the beginner file writing. And so I'm gonna save this as beginner. I'm gonna download it. I'm gonna open it up. I'm gonna create the new folder for it. I'm going to select the board, and I'm going to compile and push it, and I'm gonna open the serial monitor. One unfortunate thing that you're going to notice with this is how long it takes to push the code onto the board. So within our beginner and intermediate, there are a lot of things that are baked into the file that are essentially functionality that you don't have to think about. But because of that, this makes this a very long file comparatively to an advanced file. Let's see. This is about 600 lines of code before we get into the file saving material. And because of that, it's rather slow trying to push the code onto the board. We've been chatting for a moment and we're only at about 70%. So we'll just give it a second longer. Because all beginner and intermediate files have a bunch of built-in functionality, sometimes it'll be trying to do things that aren't relevant, like the ISM is the accelerometer and the gyroscope, and so it's trying a few times and then it gives up, and then we see what's actually relevant. So it's working on it successfully initializes the SD card, and then we can see testing 1 is written. It inserts a comma and a space, and that's because this is writing a comma separated file. So after each piece of the comma separated line is inserted, it puts in the comma for you. Then 2 inserted comma space, 3 inserted comma space. Then it tells us the CSV is done. If we were to look at the file again, and pull up test, this is the third time that testing 1, 2, 3 has been written, and so we can see that it's there 3 times. Awesome. Well, I hope this video is helpful, and good luck with your projects.